Did you know the deepest point on Earth sits 10,935 meters down? Drop Mount Everest into it, and the summit would still sit more than 2 kilometers underwater. Let that settle for a moment. Everest itself rises about 8,849 meters above sea level, one of the most famous heights on the planet. And even that towering mass, lowered into this single trench, would vanish beneath more than 2 kilometers of open water above its peak. This is the Challenger Deep, the lowest known point in any ocean on Earth. It lies at the southern end of the Mariana Trench, out in the western Pacific. A widely cited modern survey puts its depth at roughly 10,935 meters, or about 35,800 feet. Numbers on that scale are different to hold in the mind, so picture it differently. An entire mountain, a landmark people spend years training to climb, disappearing but without a trace showing above the waterline. What could possibly survive in a place like that? What would it even take mechanically to go down and look? These two questions are really the same question, and answering it has occupied a small handful of people across more than 60 years. This is a story about that number, what it cost to reach it, and what turned out to be waiting at the bottom. It does not start at the surface, it starts with the pressure that number represents. Before anyone can talk about reaching the depth, it helps to understand what the depth actually does. At the seafloor of Challenger Deep, water pressure reaches about 1,086 bar. That's roughly 1,071 times the atmospheric pressure we feel standing at sea level right now, without noticing it at all. Put another way, this is the equivalent of about 8 tons pressing down on us every single square inch of surface. 8 tons, 1 inch, or of the image next to the image of a person, or a viewing window, or a welded seam on a steel hull. That is the actual environment any vehicle has to withstand simply to sit at the bottom of the trench, let alone move, let alone carry someone back up again after the fact. It is not an environment that allows for a design shortcut. It is not a place that forgives a slow leak of hairline flaw in a weld. Every serious attempt to reach Challenger Deep has had to answer one basic engineering question before answering anything else. How do you build a vessel that can hold its shape against a force like that, and still return its passengers safely to the surface? For most of human history, there's no real honest answer for the question at all. The trench was simply out of reach. Eventually, that changed, and it changed with 2 men and one very unusual vehicle. On January 23, 1960, 2 men found an answer. Joaquin Picard, the Swiss oceanographer, and Don Walsh, a United States Navy officer, climbed into a vehicle called the Gaith Trieste. Together, they rode it down through the Mariana Trench towards Challenger Deep. When they finally reached the bottom, they became the first people in recorded history to reach the deepest known point of the ocean. Sit with what the moment actually represents. This happened years before the moon landing, years before personal computers, and years before any human being had gone anywhere on the planet before. They reached a point under more pressure than almost any engineered vehicle of that era had ever asked to survive. Then, having done it, they came back up safely. It stands as a singular achievement in the history of exploration, but it also turned out to be, in its own strange way, a beginning rather than a conclusion. Because after Picard and Walsh completed the first descent, almost nobody followed them down. For more than 50 years afterwards, no other human being returned to that exact point at the bottom of the world. That 50-year gap finally closed on March 26, 2012. James Cameron, known to most people as a filmmaker rather than an explorer, piloted a submersible called the Deep Sea Challenger down to the same point in the Mariana Trench. He did it alone. No crew beside him, no second pilot sharing the compartment, just one person inside one vehicle, descending toward Challenger Deep by himself. It marked the first time anyone had ever made that particular dive solo, and when he reached the bottom, Cameron became one of the third human being in history to arrive at that depth, more than 50 years after Picard and Walsh had done it first. 2 descendants separated by more than half a century, and only 3 people between them. The gap alone says something about how difficult and how genuinely rare a dive like this actually kind of is. It is not a milestone that gets ticked off casually, but Cameron's dive would not stand alone as the deepest for very long. Within just a few years, a different expedition would take an entirely different approach to the trench, a single historic descent, but a deliberate, repetitive campaign of dives, aimed at settling the question of its true depth once and for all. That expedition belonged to Victor Vescono. In 2019, his 5 Deeps expedition sent a submersible called the Limiting Factor down to Challenger Deep, not once, but across several separated crew dives. It was a different kind of project than anything that had come before it. Less a single, careful, historical trip, and more a sustained program of returning to the same extreme point again and again. Those repeated dives produced a new maximum depth measurement, somewhere between 10,925 and 10,928 meters. That made it deeper than the previous crew descent to that location, including Cameron's dive back in 2012. Think about that pace of change here. In under a decade, humanity had gone from a single solo pilot making one careful, unrepeatable trip to a program capable of returning to the same trench multiple times in a single expedition. The destination itself had not moved, but Challenger Deep was still the same forbidding coordinate of the map it has always been. What had changed was how repeatable, in relative terms, reaching had become, and once a place can be visited more than once, people start noticing details that a single dive may have missed entirely, including the fact that the bottom of this trench wasn't empty. Life does exist down there, in conditions that make the 8 tons per square inch problem look almost survivable by comparison. One of the creatures found living far below the depths where calcium shells would normally dissolve is a small amphib called Gigas. Its shell is built largely from calcium, the same basic material that dissolves relatively easy under pressure and chemistry found at those depths. So how does an animal like that hold its shell together at all, that far down, for that long? In 2019, one study offered an answer. Researchers proposed that the amphib coated itself in a kind of aluminum hydroxide gel, a protective layer that shielded its calcium-based shell from dissolving in the surrounding water. It was, on its face, an elegant explanation. A tiny creature manufacturing its own chemical armor simply to keep existing somewhere that should be actively destroying its shell. For a few years, this was the accepted story about how this amphib survived. Then a more careful follow-up study went looking for the same aluminum coating using improved imaging tools that hadn't been available before. It was rather different from what everyone expected. That follow-up study, published in 2022, and its conclusion undercut the earlier findings almost entirely. Using better imaging, the researchers found no evidence of any aluminum coating on the amphib at all. The original aluminum signal, it turned out, appears to have been a simple measurement mix-up with a different element entirely. Bromine really is concentrated on the animal, generally present in parts of its gut and along with its bristles. But it is not the aluminum shield that the earlier study had described. So what exactly protects this amphib at that depth? The 2022 research pointed to something else, a shell reinforced with magnesium-sustained calcite, a modified version of the same calcium-based mineral, strengthened in a way that resists dissolving even under extreme pressures. That explanation is now considered the more likely one. The aluminum shelled idea, once treated as a settled discovery, is now considered doubtful rather than confirmed fact. It is a useful reminder that even research conducted at the bottom of the ocean is not immune to basic case of the mistaken identity in the lab. Getting this particular story right, it turns out, took 2 separate trips through the data, as well as 2 separate expeditions to the trench itself. Life is not the only thing found down there that, by a reasonable expectations, should exist at that depth. So is ordinary trash. This deep-sea debris database, compiled by the Japan Agency for Marine Earth Science and Technology, known as JAMSTAC, draws on decades of submersible and remotely operated vehicle dives conducted across the world's ocean. Tucked inside the database is a photograph of a plastic bag recorded at a depth of nearly 10,898 meters inside the Mariana Trench itself. As far as the record shows, that makes it the deepest place of plastic debris ever documented anywhere in the ocean. Sit with the distance again. 10,898 meters is only a few dozen meters short of the trench's own deepest known point. A plastic bag, drifting down through the entire water column above it, came to rest almost exactly where Picard, Walsh, and Cameron had each fought so hard and waited so long to reach. It did not need a bathyscaphe built to withstand 1,000 atmospheres. It did not need a solo pilot or a purpose-built titanium hull or 6 decades of engineering progress. It simply sank, and on its own, all the way to the bottom of the world. That photographed in the database was not an isolated case either. In 2019, during those same recorded settling dives, Viktor Vineskov piloted his own submersible at the very bottom of the Challenger Deep, and there, on the seafloor, he reported seeing what appeared to be a human-made trash. Among it, a plastic bag of what looked like food wrappers resting at a single deepest known point in any ocean on Earth. Uva had traveled there as an explorer, as part of the expedition built specifically to push the limits of crude deep-sea diving. Greeting him at this destination was ordinary household waste. Species, not a new dramatic geological formation carved by pressure and time, just trash, sitting at the bottom of the world in a place fewer than 24 human beings have ever physically visited in person. It raises the obvious question, one the whole story keeps circling back towards: how did something so ordinary get to somewhere so extreme, faster and more easily than any person alive ever managed to? Go back to where this all started. An entire mountain, Everest itself, could disappear into the Challenger Deep within more than 2 kilometers of water still covering its summit. That is the scale of this place. It's a scale that has resisted nearly everyone who's ever tried to reach it in person. Only a handful of crews have ever dived and actually touched that seafloor. Picard and Walsh in 2016, Cameron alone in 2012, and Vescova's team repeatedly in 2019. Each expedition pushing the measured depth and the historical record a little further than the one before it. And yet, in that same place, under the same immense pressures, a small infant carries on, its shell held together by mineral structures scientists are still working to fully understand. Meanwhile, a plastic bag lies nearby on the same seafloor, having reached the deepest point on the planet with no engineering, no funding, and no crew at all. That contrast is worth sitting with. A 6-decade human effort involving bathyscapes, solo pilots, and repeated expeditions, set against a piece of household waste has simply drifted down on its own. Both ended up in the furthest edges, are worth your time. Consider staying close to the channel for the next descent. There is still a lot more of Earth left to explore, and more of it left to explain.